So today, another architecture we are going to uh, learn like VGG16. Last time we have already learned about LayNet, AlexNet, then transfer learning, etc. So you know now what is transfer learning. Then again, in the first module you have seen about, not first module, skip LA. You have learned about what is striding, what is max pooling, everything. So now onwards we are going to start with the architectures, convolutional neural network architectures. So whatever terms you have studied in your unit 1 or now you have studied just before these architectures, all those things will be utilizing here. For example, optimization algorithms, hyperparameters, then convolution layers, activation functions, ReLU, for example, ReLU, softmax, etc. So everything should be there in your mind. Okay. So VGG16 is a very large neural network. And why this VGG16? 16 is called as 16 convolutional layers. Okay, there are 16 convolutional layers for VGG architecture. That's why this is called as VGG16. And see, for example, if I am going to take this one. In this architecture, there may be pooling layers are there. Just count how many layers are here. If you are counting convolution 1, 1, 1, this one 2, this one 3, this one 4, this one 5, this one 6, like that. If you are counting, then it will be more than 16 layers. So don't confuse with convolutional layers and other network layers. Pooling layers, it is not pooling, it is pooling. Okay. It's the mistake of that wording. Okay, architecture made the small mistake is there. It's not pooling, it is pooling. Please not. I will write here itself. 1 second. This is called as pooling layer. So don't confuse with convolutional layers with other network layers. Okay. So VGG16 means I said that 16 convolutional layers. 16 convolutional layers means this one 1, this one 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 convolutional layers plus 3 dense layers. Dense layers is again convolutional layers which are called as fully connected layers. We can say fully connected layers. These are giving the output. After all these convolution operations, we are going to get the output after the dense layer. So what is written here? It is 224, 224 into 3 by 3. That means this is the image input size of your architecture. So each architectures, if you are studying each architectures having separate input size, image size. So we have to transform our image into this particular size, that is 224 by 224 into 3. After that, so here the input image will be your 224 by 224. Okay. Then after that, what is that 3? 3 is what? 3 is nothing but RGB channel. RGB, 3 channels are there. That is 224, 224 by 3. After that, this input image is going to 2 convolutional layers, right? 2 convolutional layers, and here there is a 64 is there. The size is again the same. Here the input size is given to the convolution layer. So the input size will be the same 224, 224. And what is this 64? 64 is the 64 filters. That means 64 channels. We are having 64 filters with this 224, 224. So there are 2 convolutional layers with 64 filters. After that, we have a blue layer. Here you can see a blue layer that is called as the pooling layer. Okay, this is the pooling layer. And pooling layer, what it will do? You all know pooling means after padding it will pull out the things. After that it again goes down. After pooling, the size will be again comes to the 112. Okay, 112 by 112, 112 by 112 with how many filters? With 128 filters. So after the first pooling layer we have 128 filters. Okay, for the first pooling layer we are having only 64 filters. Okay, understand? After this 128 layers, again we have two convolutional layers. Sorry, again we have a max pooling layer. Okay, pooling itself is max pooling and average pooling. So max pooling, what will do? Max pooling will it's a feature extraction process. Convolution network will itself extract the features. So pooling, what does I mean? I'm not going to repeat this again because we have already studied pooling, striding, padding, everything. But here for your ready availability, I am again telling max pooling will be figure out all the maximum features, everything your image will see by a neural network as pixels, so everything will be a mathematical form. So it the maximum features, which are the maximum pixels in your image, it will be taken by this layers, and we are making reducing the size. Then after that pooling layer we are having again the 56 by 56 layer, right? After here we are again going for here 56 by, sorry, 1 second. Okay, again I'm taking this one. So I have reached here, right? Something happened here, so that's why the previous values have gone. So from here itself I will start again anyway. So here it will be 56 by 56, right? 56 by 56. And how many filters are there? How many filters are there? We have 256 filters will be there. Okay, how many? 256 filters. Then after that again the next three convolution layers, then again pooling will come. Then after that again we are having a 28 by 28, 28 by 28 size. Okay, 28 by 28 with the filter 5, with filter 512. Then after that again we are having, sorry, 512 will comes here. Then again 14 by 14 size, image size will be there again with the same 512 filters will be there. Then after this the last max pool layer, from here where it goes, from here it is going to the 3 dense layer. 3 dense layer means 3 fully connected layer. So in previous all convolution layers we are having the ReLU function. Here it is written activation functions as ReLU. What will this ReLU do? ReLU does, ReLU will, I mean, why we are using ReLU? Because we don't want all the negative values to get passed on. Because if negative values are coming, first of all, it is redundant. We don't want negative values, and again computational complexity is increasing. So we can remove this ReLU. For removing the negative values, we are using ReLU function. Then at the last, we are having a softmax function. This is for the last layer. Here it will be the softmax, and for these two again it will be ReLU only. Okay, here though these two layers will be ReLU only though. So what is the purpose of softmax activation function? Softmax, when we are using it is for binary classification. If it is 0 1, then we are using this softmax classification. Okay, so if you want to get more clear idea, the same thing I am going to explain here. Here. So this VGG refers to the visual geometry group. Of this group have formulated this VGG from the University of Oxford with the 16 network layers. Okay, these 16 layers having weights, and this is a very large network because it has 138 million parameters. And basically VGG16 is used for what? Image classification and image recognition tasks. Then again here the striding is one, same padding is using max pooling layer with a 2 by 2 filter size. And all these filters, which filters? Here we have seen this 3 filters, 64 filters, 128, 256. All these filter size is 3 by 3, but whereas our padding size is 2 by 2. Sorry, max pooling layer filter size is 2 by 2. And in max pooling we have a striding of 2, but in all other filters we are having a striding of 1. And how this VGG16 is arranged, it is arranged as convolution layers, then pooling layer, convolution layers, then pooling layer, etc. And finally we have fully connected layers with a final softmax output. That's why here it is written 2 fully connected layer, and the last one it is shown as dense layer. It is giving the output for the softmax function. Okay. And here there is a link for the VGG16 implementation. I will give another video for the implementation alone because I cannot cover everything in a single video. Okay, thank you.